Welcome to the third video about Bali Unit for LotusScript, a unit testing framework adapted from VoltScript for LotusScript. In the first video, I talked about the project on OpenNTF and to access the code and to do all the peripherals, you need to go to the source control area. That takes it across to the project, and we've got the releases where you can actually download a specific release. And in the second video, I walked through downloading that code, importing it into a script library, and the basics for setting up a simple example and the difference between a Bali test runner and a Bali test suite. In this video, we're going to go on from this script library and look at some examples. So first off, we'll go to an agent, and to get to those examples, they're available in the project docs here. We've got the unit test output, and we've got the individual unit tests themselves. So first off, we're going to go into the basic tester, and this is a set of unit tests that test the wide variety of the functionality that's available within Bali Unit. Now, when you run these tests, there will be failures, there will be errors. That's deliberate so that you can actually see what those look like and what kind of output you should expect from those. So don't expect them all to run successfully. We've got a number of test suites here. I typically tend to create a separate function for each test suite. I create the test runner at in the initialize, and then I pass that test runner into each function, and each function then creates its own test suite and adds that test suite to the test runner. I found that a nice way to compartmentalize each set of tests and make them easy to work with, comment out a single bunch of tests if I need to for any particular reason. By default, when you create a Bali test runner or a Bali test suite, it will output as HTML. Here, I'm setting the output format to both. That means it outputs as both HTML files and a single XML file for the whole test run. That XML file is in standard JUnit format, and it means that you can use that code with a automation system like Jenkins as part of your build process, and we do use that in that way for VoltScript. As I said, it outputs by default to the unit-test-reports directory under whichever program is running it. So if I'm running this from the Notes client, it will be under the HCL Notes directory. If I'm running it scheduled on a server, it will be under the Domino directory. Obviously, because we're outputting it as HTML, it can easily be integrated into your project reports along with documentation and those kind of things. But it also means that it can be easily picked up by something like Jenkins for the automation. You can change the output location to a different directory name. If you want to use a different directory name for everything, then the best way to do that is to change this base report lock constant in the script library. There is a method that's available on the test runner and on the test suite called output2, and that will change the output location for the test runner or for the test suite if it's a standalone test suite, if it's not being added to a test runner. Obviously, it makes no sense to output a test suite that's part of a test runner to a completely separate directory. So if you're calling runner.addTestSuite, it will inherit the output location for the test runner. So then you're ready to write the tests. So let's just look at the test booleans and strings one for a start. That's a fairly simple one. So one thing, so out of the box there are quite a number of assertions that are available. If we just look at the documentation here, the type ahead, then we'll see we've got quite a number of different assertions there for various different data types, for strings, assert false and assert true, assert is for a particular data type to check whether the actual is of a particular data type, and that's using type name, which for a scalar or for a class returns the data type or the class name as uppercase. We're doing a comparison when you test that, so you don't have to make sure that you get it as uppercase. We've got some additional assertions for ranges. In my experience, those were added in. I added those in after I'd first created the test suite because I wanted to do some range testing. But in my experience, the easiest way to do that is just to do an assert true or an assert false and check the range there. Obviously, we've got the assert equals. We've also got assert not equal. And we have assertions for primitives that will compare two primitives, checking the data type and CSTRA, the value, and arrays as well. So we've got a whole host of assertions there that should cover every particular option that you might need. So assert true, you just pass in a value to check whether it's true. For the assert equals and assert not equals, then you will pass in an actual value and an expected value as the first parameter and an actual value as the second. And it will check those, and if it doesn't match, then it will tell you what was expected and what was actual. Obviously, for the range ones, then there's more options that are being passed in. There's a starting range and end of the range, and the actual value. For strings, we've got a third parameter there for whether or not to do case-sensitive matching. Now, the assertions, we're wanting to limit the number of assertions here. We don't want to cover absolutely every possibility that you might ever want to create, because then it makes it difficult to work with. So we're only covering, for the case-insensitive matches, we're only lowercasing the value. We're not checking pitch and those kind of things. If you want to do that kind of testing, then the recommended approach would be to use an assert true and run an option compare. Primitives, the one I was wrong on on it checking the data type. It doesn't check the data type. So we've got a test number and string. It just cstras the values, so a number will match a string. If you want to ensure that it's numeric, then do assert equals numeric, or do assert is first. We can capture variants, and we can also capture variant arrays as well. So if we run that, then we can have a look at the output, and it creates a directory with the name of the test runner and then date and time that it was run. We've got the XML format here, and if we just open that up, then we'll see it's XML, and it's just a standard XML that you get from a JUnit output with test suite, test cases between them, and then a separate element then for each test suite and each test case. If we go to the index.html and open that up, then we can see the HTML output. And obviously here we've got no completely successful tests. Red with an X means that there was an error. The blue just means that it was failed tests. So when we click on an individual test suite, the output here and the look and feel of it is what you would see in a JUnit output, for example. So we've got the duration that that test suite took to run, the amount of tests that were in it, the number of tests that had errors, and the number of tests that had failures. If we click on a successful test, obviously there's no further information. If we click on a failed test, then we can see that it was expected to be true but was false. If we've got an error, then we'll see the error line number and the error message and error code for it. So that's all fairly straightforward, and you can easily quickly see which tests were failing and why. Arrays, again, there with throwing a failure if one is an array and one is not. So here the expected is an array, but the actual is not an array. It's just a single value. Equally, we're checking the number of elements in the array. If the number of elements is different, then there's no point even testing the elements in there. We just throw up the error that there were 8 elements in actual, 8 elements in expected, 1 in actual, and therefore it's not a match. When we're testing individual elements in an array, we're testing element 0 in the expected array against element 0 in the actual array. We're not checking that the arrays have the same values but in different orders. We're expecting the same order. If they don't match, then we're outputting the expected and the actual, but we're also then adding into the stack which element was not matching. So here it's element 1, this first one here. Expected was 0 and the actual was 1. If we've got more than 1, then again we say which elements were different and what the expected was and what the actual. We cap that at 5. If you've got more than 5, then you've got a significant problem, and knowing the 6 is not going to be helpful, really. So that's a basic test. On the next video, then we'll go into looking at more ad hoc testing without using the individual assertions, and we'll also go into running functions before and after each test, and custom tests as well.